This video will talk about some basic concept of the probability, so which may be the prerequisites of the introduction to econometrics. So in this video, we will talk about some expected values, variance, probability distributions, and in later part, we will talk about the relation between two random variables, and at the end, we will talk about the distribution of the sample average. Okay, let's get started. So the first concept is called the expected values and the variance. So what is the meaning of expected value? So expected value of y, you need to first find out what are the values of the y. So maybe you have y1, y2 up to yk. So you need to find the probability incorporates to the y. Okay. So say if the value of y can be equal to y1 with probability p1 and with probability p2 with the value y2, and at the end you with the probability k with the value of yk. So the expected value of y will be equal to p1 times y1 plus p2 times y2 plus ... up to pk times yk. So in short, we can have a definition of the expected value that summation from I equal to 1 to k pi times ki. So you just need to multiply all the, there's typo here, py times yi. So you just need to multiply all the value of y times the probability p. So let's take a look at the examples. So say the value of y can be taken 4 values, 1, 2, 3, and 4, with the probability 30%, 20%, 40%, and 10%. So the expected value of y is simply equal to the value of y equal to 1 times the probability 0.3 plus the value of y equal to 2 times the probability 0.2 plus the value of y equal to 3 times the probability 0.4. Finally, plus the y equal to the value of 4 times the probability 0.1. At the end, you will get that expected value of y is equal to 2.3. So easy, right? So next, take a look of the special random variables distribution, which is called Bernoulli random distributions. So the Bernoulli random variable is simply say that, okay, the value of g can be taken equal to 1 with probability p and 0 with probability 1 minus p. So the Bernoulli distribution just take two values, 1 and 0, with probability p and 1 minus p. So the expected value of g is simply equal to 1 times p plus 0 times 1 minus p, which is equal to p. Okay, so this is the concept of the expected values. Next, let's take a look at the variance. So variance has this symbol called sigma y squared, which is equal to variance of y. So in order to calculate the variance of y, you need to take this form, expected value of y minus mu y. So mu y here just equal to expected value of y. Okay, y minus mu y, then the whole term square it. So in mathematical terms, it can be equal to the sum from I equal to 1 to k times yi minus expected value of y squared times the probability. So let's go back to our examples. So still remember the value of y can be equal to 1, 2, 3, and 4 with the probability 0.3, 0.2, 0.4, 0.1. So how to find the variance? So before you find the variance, first you need to know what is the value of mu y, which is the expected value of y. So in our example before, we calculate the expected value of y equal to 2.3, which is equal to mu y. Okay, so you need to make use of this information to calculate the variance of y. So here, the variance of y equal to the probability 0.3 times the value of y, yi here, 1 minus the mean, 2.3, don't forget to put a square here, plus the second probability, 0.2, multiplied by the value of y, that is 2 here, minus 2.3 square, plus probability 0.4 times the value of y equal to 3 minus the mu, finally, plus probability 0.1 here times the value of y4 minus the mu, take the square. Then you just plug in all the value into the calculator, and you will find that the variance should be 1.01. Okay, so you just need to multiply the probability with the value of y minus the expected value, then take the square term. You can calculate the variance. So let's take a look of the another examples. Go back to the binomial distributions. So the g can be taken into 1 and 0 with probability p and 1 minus p. Okay, and you know that the expected value of g is just equal to p. So how to find the variance? So the variance is just simply equal to the probability p times the value of the g, 1 minus the mean. Mean is the p. Take the square term, then plus the probability 1 minus p times the value of g, 0, minus the mu, then take the square. So what is equal to? So it equal to p times 1 minus 2p plus p squared, plus 1 minus p times p squared. Then you further do the simplifications. P minus 2p squared plus p cubed plus p squared minus p cubed. Then you can see that, okay, this to the power 3 can be cancelled. What is remains p minus p squared. That is equal to p times 1 minus p. So you can see that with the binomial distribution, the variance of the binomial distribution is just p multiplied by 1 minus p. Okay, so these are the concept of expected value and the variance. So next we will talk about how to find the probability distributions. So the probability distribution mainly covers 3 types of distribution: the joint probability, the marginal probability, and the conditional probability. Okay, so for the joint probability, it means that the probability that the x equal to some kind of value and y equal to some kinds of values. So let's take a look at the examples. Here, 0.037 is the joint probability that x equal to 0 and y equal to 0. And 0.622 here is the joint probability that x equal to 0 and y equal to 1. So all the 4 boxes here refer to the joint probability. Okay. Second one is called the marginal probability. So based on the name, we know that marginal probability is something related to margin. So for example, if I ask you what is the probability that y equal to some kind of value, you need to tell me, you need to look at the margin and see what is the answer. So let's take a look. If I want to find the probability that y equal to 0 in this example, so what should we do? Okay, first take a look, where is y equal to 0? Y equal to 0 is here. Okay, y equal to 0 means the unemployed. So the probability that y equal to 0 is mean that, okay, what is the value if I either pick one person? The chance that we get y is equal to 0. So in mathematical term, we want to find out that the probability that when x equal to 0 and y equal to 0 plus probability that x equal to 1 and y equal to 0. Okay, because we know that for all the elements in our sample, x can be either 0 and 1. Okay, no other options, only 0 and 1. Therefore, if we add up all the value of x equal to 0 and 1 in the y equal to 0 case, we can find the probability that y equal to 0. So on the other hand, if we want to find the probability that y equal to 1, so this is simply equal to probability x equal to 0 and y equal to 1 plus probability that x equal to 1 and y equal to 1. Okay, so let's continue. So finally, the conditional probability. So the conditional probability has the form that p probability y equal to y, a vertical stroke, and x equal to x. So this means that what is the probability that y equal to some value given x equal to some value. So the definition of the conditional probability is that, okay, given this term, how to calculate the value. So you need to calculate the probability that y equal to y and x equal to x divided by probability that x equal to x. So you can see that the conditional probability equal to the joint probability divided by the marginal probability. So for example, if I want to calculate the probability that y equal to 0 given x equal to 1, okay, that means given x equal to 1, we just focus on x equal to 1, this row. What is the probability that y equal to 0? Okay, so how to calculate it? So it is equal to probability that y equal to 0 and x equal to 1 divided by probability that x equal to 1. Okay, so why don't we try to calculate the numeric value? So this is equal to, what is the probability that y equal to 0 and x equal to 1? So we go here, probability that y equal to 0 and x equal to 1 is here, 0.009 divided by probability x equal to 1. So what is the probability that x equal to 1? So we go here, we can see that probability x equal to 1, this is equal to, you add up all the probability that x equal to 1 and y equal to 0 and probability that y equal to 1 and y equal to 1. That is equal to 0.009 plus 0.332. So this is equal to 0.02639. Okay, the implication is that given x equal to 1, that means given that there is a college graduate, what is the probability that y equal to 0? So y equal to 0 means unemployed. So this probability show that, okay, given this population or given the person you draw from the sample is a college graduate, what is the probability that he or she is unemployed? So this is just 0.02639. Okay, so this is the implications. So next, given these three probability distribution, we can do some conclusions, or we can go to another concept which is called the conditional expectation. So next, we want to know is what is the conditional expectations. So conditional expectation means that given some condition, what is the expected value of y? Okay, before you know that, what is the expected value of y? Okay, expected value of y is just the value of y times the probability that equal to that value. Okay, now we put a vertical stroke and x equal to x. So that means that we want to find the value of y, multiply the probability that y equal to that value given the x situations. So mathematically, it has the terms like this. Expected value of y given x equal to x is equal to summation of I equal to 1 to k times the value of yi multiply the probability that y equal to yi given the x equal to a certain value. So to be more specific, let's take a look at some examples. So if I want to calculate the expected value of y given x equal to 0 and expected value of y given x equal to 1, so how can we solve these questions? Okay, so take a look of our example. So take a look of our examples. What is the minimum expected value of y given x is 0? That means what is the probability that the one is employed given that first they are non-college graduate, the second is the college graduate. Okay, let's try to do this first. So what is the expected value of y given x is equal to 0? So here is the data. Okay. So if you want to calculate the expected value of y given x is 0, you need to use this formula. Okay. So y can be taken be either 0 and 1. That means you need to first add the value of y equal to 0 times the probability that y is equal to 0 given x equal to 0. Then plus the value of y can be either taken to be 0 or 1. So the second one is 1 times the probability that y equal to 1 given x equal to 0. Okay, here you can see that this is the conditional probability. This is conditional probability. But luckily, everything multiplied by 0 is 0. So the first term can be ignored, right? For the second term, 1, I just copy down. Then the conditional probability, which means the joint probability divided by the marginal probability. So by simple math, we know that, okay, the joint probability that x equal to 0 and y equal to 1, that is equal to 0.622 divided by the marginal probability. So the marginal probability is you add up all the value of y equal to 0 and 1 given x equal to 0. This is 0.037 plus 0.622. So at the end, you can find that the expected value of y given x is equal to 0.94385. Okay. So you can use the same skills to calculate the expected value of y given x is 1. So maybe I leave it for your practice, and at the end you should calculate the value of expected value of y given x is 1 is equal to 0.9736. Okay, so try this by yourselves. Okay, at the end of this video, I would like to talk about the very famous law in the econometrics, which is called the law of iterated expectations. So the law of iterated expectation is in this form. The expected value of y is equal to expected value of the expected value of y given x. Okay, so this law is very useful in higher level econometrics, especially you want to find the expected value of u, the error term, given some x is equal to 0. So this is the first step to talk about what are the basic assumptions in the econometrics. But before that, you need to know how to use this law. Okay, so this is the law, and you need to know how to prove it. So I would like to prove it now. So why they are the same? So you can use the left hand side to prove the right hand side, or use the right hand side to prove the left hand side. So this is my behavior, or I would like to do this at the complicated part first, and to prove it that it is simple. Okay, so I will start by this gigantic animal stuff. Okay, so what is the expected value of the expected value of y given x? Whenever you come across some expected value, you know there's some probability. Okay, so the first step is that you can write it as expected value of y given x equal to some sort of value xi. Okay, so this part is just equal to this part times the probability that x equal to xi. So this is the outside part expected value. Of course, you need to add up all the I from 1 to L. Okay, the value of x can be taken from the value I equal to L. So this is the first step. You expand the expected value into the expected value times some probability. Second, we want to rewrite it by a little bit. So what is the meaning of expected value of y given some sorts of conditions? So you can see that the expected value of y given x equal to some sort of value is equal to the value of y times the conditional probability. So the next step is to rewrite this statement. Okay, now you have two summation terms, I from 1 to L, and the other summation is for the y added from j from 1 to the k. So the summation of I rewrite as yj because I've used the I here already. So times the probability that y equal to yj given x equal to xi. Okay, so this part is indeed the first part. Then keep rewriting the second part, probability x equal to xi. Okay, so what should we do next? So how to calculate the conditional probability? We have the law that conditional probability is equal to the joint probability derived by the marginal one. So we just keep to rewrite it, yj times the joint probability derived by the marginal probability. Then keep rewriting the second part. Okay, here you can see that this part and this part can be cancelled. So what is remaining is just added from I equal to 1 to L, from j from 1 equal to k, yj times probability that y equal to yj and x equal to xi. Okay, here you can see that if I group this summation term and put this here, and we can see that, oh, this is just sum of yj from j equal to 1 to k times the sum of the probability that x from x1 equal to xl. Okay, so this is just equal to j from 1 to k yj times the probability that y equal to yj. What is this? This is just expected value of y. So here is the proof of the law of iterated expectations.